Our next session is Oracle Data Redaction is Broken, and your speaker is David Litchfield. Thank you.
Okay, so I'm guessing everyone missed the memo, so those at the back, if you want to come forward, it makes me feel like I've actually got an audience to speak to today, Okay, so who am I? My name's David Litchfield. I've been an IT security consultant for a very, very long time. I'm currently working for an organization out of Australia called Datacom TSS. I used to work for some American companies, and a while back I set up my own company, NGS, which sold to NCC back in 2008. So my job used to be to break into systems, essentially a C&E specialist. We would have clients who would come along and say, please do this kind of assessment for us, and we would tell them where the problems are and how we got in and everything like that. I started out in buffer overflow exploitation. Back in 1999, I wrote a paper on a buffer overflow vulnerability in the Razman service on Windows NT, and I knew at the time I discovered one of these magical buffer overflow vulnerabilities. You could execute arbitrary commands and everything like that, because I'd read a paper by Aleph1, smashing the stack for fun and profit. And I was like, right, I found one of these super duper magical things. How do I go about exploiting that now? So as I learned the process, I documented that, buffer overflow for beginners and stuff, and moved on from there. So when it came to 2003 and Microsoft had started implementing the GS flag in the compiler, I spent some time reverse engineering what was going on and wrote a couple of techniques to bypass their stack protection stuff and safe SEH, safe structured exception handling. To be fair, that's probably the pinnacle of my career. I don't think I've done anything since that, in computer security anyway, since that time. Because, hey, I moved into database security, and it's trivial, it's easy, and, well, it should be really called database insecurity. I'm an author. I've written the Oracle Hackers Handbook, the Database Hackers Handbook, and some chapters in the Shellcoders Handbook, the first edition. If you're interested in this kind of stuff, I can be followed at dlitchfield on Twitter, or if you actually want to have a conversation offline, I can be emailed at david.litchfield@datacom.com.au. With that over, I want to set the groundwork for this talk. So recently, at the beginning of the year, the Oracle CEO, Mr. Larry Ellison, said, to the best of his knowledge, an Oracle database has not been broken into for a couple of decades by anybody. To be fair, he said the same thing 10 years ago, and at that time he said 10 years. Now, who remembers the Sony PlayStation Network breach in 2011? That's running Oracle. The fact that the biggest data breach at that time, that the senior management at Oracle is not aware that that was an Oracle database server is awful as far as I'm concerned. The senior management should know of every single breach, especially their biggest customers, when they're happening, or when they're discovered at least. The Oracle CSO said at one point, customers should hold their vendors to a very high standard. The only way you can hold your vendor accountable is through your pocketbook. In other words, if your vendor is failing you, vote with your checkbook. Don't buy their products if their products are crap. So we'll do some history. How I got into some of my checkered history with database research anyway, and some of the problems I've had with Oracle in the past. We'll be talking about Oracle Data Redaction at the very end of this, and I'm using Data Redaction as an example of how they've not actually made any improvements, and it's 2014. The rest of the world got the idea a long time ago. So who remembers a hacker called RFP, one of the great researchers of his time? I know he's still around and everything like that. But he wrote some really cool white papers on like how I hacked WW threads and everything like that. And it was using things like SQL injection. And I didn't know anything about databases at the time, so I started researching databases because of the work RFP was doing. And a colleague of mine, Chris Anley, and I were doing an assessment for one of our clients. This is back in 2000. And we basically broke in through a SQL injection attack and basically extended what was known at the time using things like group by clauses to get information about the database structure. And I wrote a paper on this called ODBC, Web Application Disassembly with ODBC error messages. And it was one of the first few papers on SQL injection. Then I did some work on Microsoft SQL Server. Again, there was myself, Chris Anley, and a guy called Cesar Serrado, who at that time were beating the crap out of Microsoft SQL Server. And I found a couple of buffer overflows in there, well, more than a couple. Specifically, though, one of those was exploited by the Slammer one. Who remembers what happened on January the 5th, 2003? Slammer, of course, probably a lot of people got angry, call, like 3 o'clock in the morning, come and fix our, internet, it's broken somehow. That was probably Slammer. Indeed, large portions of South Korea disappeared off the net for a wee while because of it. And when I found the flaw that Slammer ended up exploiting, I worked with Microsoft, and they got a fix out, and it was at Black Hat 2002 actually, in crumbs 14 years ago, or 12 years ago rather. I'm getting old. I spoke about the flaw that Slammer was exploiting. I said, if you don't fix this, this will become the next big worm. And 6 months later, Slammer came out. But then, at about that time, Larry Ellison turned around and said his products were unbreakable. And when a hacker hears something like that, you do an about turn and you say, what? People talk about the assassination of John Kennedy. Everyone can remember what they were doing at the time when they heard that John Kennedy had been killed. That was the same for me. When Larry Ellison said his product was unbreakable, I remember exactly what I was doing, and it was looking up from my keyboard going, what? So my attention and my brother's attention turned to Oracle, and within a day, we had sent Oracle about 35 critical flaws, most of them not requiring a user ID and password to gain full control of, and thus begun my relationship with Oracle. And I'm going to skip a lot of this because it's really quite boring. Actually, no, let's go over this. So one of the flaws which was really interesting, and this speaks to about the way Oracle approaches security. One of the flaws is the launching of external procedures. Now, for those that don't know Oracle too well, as in the RDBMS, essentially what happens is you have PLSQL, which sort of extends the features of SQL, and it's programmable, it's a procedural language and everything like that. And essentially what you can do is if what you want to do, you can't do in PLSQL, you can shell out to a shared DLL, a library, and have some C code do that for you. Now, the way in which that works is the PL SQL package turns around and says, connects to the TNS listener. The Oracle database connects to the TNS listener and says, please load this library, execute this function, and pass it these parameters. And the TNS listener goes, well, no, I won't do that, but I know a program who will, and that's called xproc. So xproc goes ahead, loads the library, executes the function, and with the supplied parameters. So you can just look at that and think, well, there is no authentication taking place there. And so if I'm across the other side of the network, I can connect to the TNS listener and pretend to be the Oracle RDBMS process and say, will you load this library for me and execute this function and pass it these parameters? And lo and behold, when you connect, TNS listener turns around and said, well, no, I won't do it for you, but I know a program that will. And it goes ahead and faithfully launches xproc, and xproc loads the library and executes the function. So, of course, someone could load libc or msvcrt.dll and execute the system function, passing it command, whatever command they want it to run. So on Windows, that runs as local system, and you can, you have complete control. If it's running on a Unix-based system like Linux or whatever, then it's going to run as the Oracle user, or it did at the time. It's now should be running as nobody. So I sent this to Oracle, and they attempted to fix it, and they fixed it on certain versions, but left other versions vulnerable because they decided that those products were no longer going to be supported anyway. So their fix basically said, well, what we'll do is allow the person to still connect to us and attempt to load the library, but we'll be cunning about it. We'll log it. We'll log the attempt. So if you send an overly long library name, there's a buffer overflow with an unsafe call to sprintf. So we could still gain control without a username and password when it's logging it basically by exploiting the buffer overflow in sprintf. So we sent that bug to Oracle, and they fixed that one too. And they put some length checking in there. And what they do now, or did at the time, was say, what's the length of the library being requested by the user? If it's over 256, deny the request, don't even log it, we'll just drop it. If it's less than 256 characters, we'll go ahead and log the attempt. But before they do the call, the unsafe call to sprintf, They didn't change it. They didn't patch it by calling snprintf and specifying the number of bytes to copy. They left the sprintf in there, the dangerous one. And, but before they did the logging, what they did was expand any environment variables in there. So they do the length check first, and then they expand the environment variables. So if you have $path in there, that expands to the length of the path. So basically, we have 5 characters extending to potentially, 200, 300, or whatever. So guess what? After the length check, and through the expansion of environment variables, we can still gain control over the process as path of execution simply by, again, exploiting the unsafe call to sprintf. They attempted to fix it again, and there was another flaw. But let's move on from there. I want to give you another example. That was about 3 years to get to the point where it's still vulnerable. So Oracle Application Server, it's a common web server. Essentially, there's a thing in it called the mod PL SQL gateway. It's actually quite good, and essentially what it does, it allows you to program a web application in PL SQL and have those calls executed over the web. But the way in which it operates is a web user will make a request, www.example.com/pls/dad, the name of the PL SQL package, the name of the procedure, and any parameters that are in the query string, question mark query string kind of. And what the web server essentially does is takes that and goes, there you go, database server, execute that for me. So with no validation. So if you know there's a vulnerable package and the name of a vulnerable procedure, we can just execute it directly. So that was definitely a big risk. So I sent that to Oracle, and they protected it by having the PLSQL exclusion list. And on that list is anything in the sys schema, anything that starts with OWA, because there was like OWA _util.cellsprint, which allowed us to run arbitrary SQL queries and so on. There's a whole bunch of OWA packages which are there to support the building of web applications that had dangerous functionality in there. Or simple cross-site scripting, http.p $cbuff cross-site scripting attack, so to speak, That's the http.p is just simply print this HTML out. So they come up with this PL SQL exclusion exclusion list. And it was trivial to bypass initially by just passing a space, So you go %20, name of package, name of procedure. And the database server would go, yep, %20 is a space, but we're going to do the validation on that now. And of course, that's not on the list. That, space sys is not on the list, so we pass it through, and again, we can gain access to everything in the sys schema. So I sent that to Oracle, and they fixed it. Oh, sorry, at the same time, of course, a new line character, %0a would work, of course, and %0d. And a tab, of course, 09. So they went ahead and fixed that. And then we were doing a pen test, and this customer had Oracle Application Server, and we had to bypass the exclusion list again to do various things. And it suddenly struck me that there's other ways to bypass it. So like if we unquote sys in double quotes, well, that's valid SQL as far as the backend is concerned. But hey, guess what? It breaks the exclusion list on the web front end. There's another way of doing it. So who's ever run char map? The character map application on a Windows system. It gives you all the ASCII characters and so on. What character is FF, hex FF? Anybody? It's like a Y with an umlaut on top of it. So I was like, no, they're not going to be that silly, are they? So %FFS dot, basically that gets, when the web server receives that, the web server goes, nope, that's not on the exclusion list, but SYS is, of course, but SY with an umlaut S is not on the exclusion list, so let's go ahead and pass it to the back end. The database server, depending upon the character set, says, I've just received this request for a funny-looking Y, with SY. Maybe they didn't mean that. Maybe they actually meant the letter Y. So let's change the Y with an umlaut, the character FF, to the letter Y. So again, we could gain control of the back end through by passing the list. So eventually, after about 5 or 6 of these, year 1, I send it, bypass again, year 2. In fact, there was another time where there was a couple of flaws in the MD sys schema. And the only way you could actually leverage these was basically through, the risk was presented through an Oracle Application Server. And they said, well, yeah, you need to bypass the exclusion list again to exploit that. And I said, well, in the past, we've had about 5 or 6 ways of doing it. Are you sure there's not any more? And we're like, yeah, we're good. We're not going to fix these flaws in the MD-sys schema. And so I was like, damn you guys, and tap, 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 tap. Sent them within 5 minutes a new way to bypass the list. This time, angle bracket, label, angle bracket. Basically, it's a go-to label. So again, that would bypass break the pattern checking and so on. Eventually, they fixed the MD-sys stuff and that new bypass, and eventually said, stop. We clearly have failed miserably on doing the validation on the web front end. Let's get the database server to do the validation. Yeah, well, that's a good idea, isn't it? The database server, the place where we're executing code or attempting to execute code, is now enforcing it. So guess what was vulnerable to SQL injection? Their validation code on the back-end database server, so we could, gain arbitrary code execution on the back-end database server. So over the years, there's been some really quirky patches come out from Oracle. So back in the days of like 2005, 2006, and so on, you would send them a proof of concept code when you discovered a flaw, and they would fix the exploit by making sure the exploit didn't work, but not actually fix the underlying flaw. And one of the examples of this is, if the input has a space in it, which is my exploit did, reject it. Not thinking that, of course, we can replace a space with comment delimiters or a double pipe for concatenation or whatever. So again, we could trivial, so you wait 2 years for a fix to come from Oracle, and the fix is broken and trivial to bypass. Sometimes their fixes used a secret. So they would have a really long string of random characters, and if you supplied that as one of the parameters, you could do, you could execute the arbitrary SQL kind of thing. So rather than not realizing, of course, that hackers have the ability to reverse engineer things and extract secrets. So we exploit it again just by passing the secret once we've reverse engineered it. Another very typical one is you would find a vulnerability, and 2 lines later, in the same bit of code, you would have exactly the same kind of flaw that they didn't fix. And again, these are the things where you wait a year or 2 years to get fixed, and the fix is not good enough. And sometimes their critical patch updates would actually replace fixed code with broken code. If a user had attempted to defend themselves by dropping vulnerable objects, well, the patch would come along and replace those objects. So if those patches had flaws in themselves, then suddenly that person, all their hard work done on locking down that database has been undone by those objects being recreated. They are a lot better today, but still a long way to go. So between the years 2000 and 2014, specifically for the RDBMS itself, none of the other products in Oracle, I'm not talking about Java here, I'm not talking about the application server or e-business suite or anything like that, just specifically the RDBMS. This is the graph of patches. Now, each one of these blue blocks basically represents something with a CVE ID behind it, essentially. So we can see back in about the year 2004, quarter 2, 2004, they were fixing things on an ad hoc basis. So, we had alert 1, 2, 3, alert, all the way up to, I think it was like 50 odd or something at the time. And they decided, because of the volume of bugs that were being found in their products, that they were no longer going to do this ad hoc patching thing. I think they were getting a lot of complaints from customers. They were going to do a quarterly patch update, which is good thinking. They were So first off, they slagged off Microsoft for adopting this policy, and then a couple of years later, they're doing it themselves. Go figure. So suddenly, in the tail end of 2004, we see all these bugs being fixed, basically, which is great that they're being fixed. And over time, we can see the graph today is almost leveling off. Maybe there's every critical patch update that comes out, there's 2 or 3 or 5. Long gone are the days where 50 bugs are being fixed, well, 28 in a single critical patch update. For Microsoft SQL Server, for all their versions, this is the same graph over the same time period. So here, in end of 2002, beginning of 2003, is where Bill Gates sent out his trustworthy computing memo. They turned around and said, we've been dropping the ball, we really need to fix this and improve our processes. And indeed, they came up with the SDLC. the security development lifecycle. Now, another interesting story about this period of time is because of all the flaws that had been discovered in SQL Server by people like Chris Anley, myself, Cesar Serrado, and all those guys, Microsoft said, stop development of Yukon. Yukon was the code name for SQL Server 2005. So they actually got the whole development team off Yukon to do a code review of SQL Server 2000. Bill Gates basically authorized that and said, look, we need to improve because we're going to be hemorrhaging customers. So the sole reason that this side of the graph is as empty as it is because of the security development lifecycle. Microsoft, that is, has done wonders. So I just want to compare them again. Oracle versus Microsoft. And I think there's some key things that we can take away from SDL here. The stuff I'm going to be talking about in terms of the Oracle data redaction and why it's broken, if Oracle had followed any decent kind of security development lifecycle, as opposed to just paying lip service, the flaws that I'm about to speak about would have been caught at every single one of these stages of SDLC. So establish security requirements, attack surface analysis, and so on, all the way through to the very last stage, conduct a final security review, pen test the product before it goes live. Now we'll see, the stuff I'm about to talk about is not rocket science, I used to do buffer overflow exploitation and defeat stack protection and safe SCH and everything. This stuff is kindergarten stuff. No one should be releasing a product in their flagship product, Oracle 12c, with these kind of flaws in it. They should have learned this lesson a long time ago. In fact, before I sort of went into semi-retirement, and at that time I gave Oracle a B+. They were actually doing really, really well. So I'm being slightly unfair to a certain extent because they actually have done great work in terms of improving the security of their products. So Peel SQL injection flaws are almost entirely gone now. Indeed, if there are any, it's through things like numeric lateral SQL injection. It's things like PL/SQL race conditions. They're very edge cases, I have about 15, since starting back into Oracle research back in November, I think I've still got about 15 outstanding issues that are waiting to be patched, some critical, some not so much. And yet, it's 2014, and I'm still managing to sit down in the space of a few minutes and find bugs and send them to get them fixed. This should not be happening. So let's talk about Oracle data redaction. Actually, I wanted to go back here because I don't want to make it sound like a Microsoft fanboy. Same vulnerability you reported 2 lines further into the code. Who remembers the iRemote activation flaw? Last stages of Delirium, a Polish group, found a buffer overflow in DCOM. The iRemote activation was the interface, and you could trivially exploit it to gain code execution without a username and password. It's what Blaster eventually ended up exploiting. So as it happens, Microsoft fixed the code for it was a simple stack-based buffer overflow. But 2 lines further down in the code, there was a heap-based overflow. So it's not that missing vulnerabilities is simply an Oracle problem. Other vendors do it too. By the way, the thing about the Microsoft fanboy thing, I am a fanboy. I do like them. But just being fair, patches missing, yep. So Oracle data redaction is a really great idea. Basically, if we have sensitive data, we can turn around and hide it from the end user if we so choose, which is great for things like if your application might be vulnerable to SQL injection. For example, let's look at eBusiness Suite. Who knows how many JSP files are in an installation of eBusiness Suite? 1,000? Show of hands, 1,000? 2,000? 15,000? 15,000. There's between 15 and 18,000 JSP files. Most of them were written like in 1999 when security wasn't in the dictionary at that time, and they're still there. They're defunct, but they might be vulnerable to SQL injection. So here's a great thing. We can say, you know, our web applications might be vulnerable to SQL injection, so let's protect PII or confidential stuff and redact that so we don't have to make any changes to our applications, but we can protect it. So if someone snarfs our data, for example, Anonymous or lolsec or whoever it happens to be, basically all they're going to get is a list of X's or something like that. So it's a great idea. Problem is, of course, it's trivial to bypass. So let's actually have some demos. Right. So basically, we're going to first off set up to show you how it works. We're going to make sure the policy's dropped. I just want to clear up. OK. And then make sure this is dropped. OK, good. Right, so we're going to create a table with a credit card column. Can you guys see that at the back? You can, right, good. And insert a fake credit card number and then commit that. Control-C. OK, so if we do select star from redaction, actually, why am I typing when I can cut and paste? OK, so we can currently, of course, see the credit card number, you know. So we would want to redact that. So what we do is essentially create a redaction policy on it. So and let's give David some permissions to see that. OK, so now, all as David sees when he logs in, let's say David is the application that's used by the web application to connect, and they're doing a SQL injection attack, and they select, you know, from this redaction test table, then they're not going to get to see the credit card information because it's all redacted, which is lovely. The problem is, well, there's several problems. Let's go through them individually. So within Oracle, there's a function called XML query, and basically that allows someone to execute xquery. And we can specify the name of a table and the owner, and return data from that. Now, if you were releasing a new product, a security-sensitive product in your flagship database product, you would think someone, as part of the SDLC, would do a penetration test on it before it goes live, or at any of those other stages during a security development lifecycle. This should have been found before it was shipped. So all we do basically is specify the credit card column, and we can get it out. We can unredact the column that's been redacted. So there, you know, is failure one. It's a bit unfair, but XML table function is also vulnerable. So there we go. Get the information back out. Another one is if you do an update, sometimes if you have a column that is automatically updated, for example, with a sequence number or something like that, you do an update through an application, and you need to know what that sequence number is so you can do a returning into subclause of the update statement. Well, of course, you know, anyone who understands SQL would have turned around during a pen test of this product, had they have done one, and said, well, wait a minute, we can get data back out via the returning into subclause, this here. And we should probably check that as part of our pen test of Oracle data redaction before we ship it. But did they? I guess not, because guess what? So all we're doing is updating the ID column with the same value, so we're not actually updating anything at all, and we can roll this back. But what we're doing is saying, once you've done the update, return whatever's in the credit card column, the CC column, and stick it into the buffer, and then print that buffer to the screen. So again, we can bypass data redaction using this as a method. Again, had someone done a pen test on this, they would have found this as a method of bypassing data redaction. There's a really, really silly way of doing it. So anything in the where clause, the bit that you on the end of the query, like select star from table where condition matches such and such kind of thing, the columns cannot be by nature protected in there. So Alexander Kornbrust actually pointed out back in November that you could pass, obviously, the column name to UTL HTTP and send out data, exfiltrate data that way. And there's a couple of other methods you can do it. Or alternatively, you can just simply brute force it. So what we're going to do here is create a simple function, a procedure rather, that attempts to verify what the data is based upon its position in the results. So all we're doing is saying if the first byte of the first row of data is 1, print it. If not, move on and try 2. And once we find the data, we move to the next character. So we do a substring on the second character of the returned data set. So basically brute forcing the space. And if we know that it's a credit card, we only have to go through numbers, obviously 0 through 9, and we have them all listed. So let's create the procedure. Sorry? I don't need to, because I've not really updated anything. But just for... Here we go. Thanks. So all I've done is created this little procedure that's going to brute force it and then execute it. So we can see, obviously, because it's not protected in the where predicate, we can get this information out. So there's ways that are clearly trivial to spot. Anyone who's worked at Oracle for the past year and has an understanding of how SQL works should have found these issues. Why weren't they found? And that's really the telling for me. It's like we're in the year 2014, and they've still not learned the lessons that people were learning in 2003. They often tout their security credentials, Oracle. And I think what they mean by that is security as defined by things like the common criteria, okay? So the common criteria is like the Orange Book stuff, Red Book, the IBM. So basically it's where the government turns around and says, if you follow these kind of development procedures and you go through an evaluation process, we will certify your product as having a high level of assurance. So if we look at Oracle 8.1.7.4, if we look at Oracle 9i Release 2, both of those passed to EAL4 Plus under the common criteria. And yet, both of those had a buffer overflow in the authentication mechanism by passing an overly long username. So all the things that the common criteria speak about, things like having logins and audit facilities and non-repudiation and all this good stuff, is defeated by that one buffer overflow in the authentication stuff. Because once we've exploited that buffer overflow, we can turn off auditing, we can turn off repudiation. My actions are not those of a logged-in user, they are the actions of the database itself. So, and again, in fairness to Oracle, a buffer overflow with an overly long username in the authentication, Infomix had exactly the same thing. So it's not like Oracle are out there alone, with these kinds of issues. And yet they have a pocketful of government-authorized credentials that says we have passed, common criteria several times to EAL4 Plus. And I think that's part of the problem is what happens is when you are measured against the common criteria, you have what's known as a protection profile. And the people who wrote the protection profile started off by saying, the installation must be on a non-hostile network. Well, Jesus, sorry, I shouldn't say Jesus. It's like if you're on a non-hostile network, well, of course no one's going to hack into you because it's non-hostile, right? Can anyone say Edward Snowden? There. That's pretty much the end of the talk. Oracle data redaction can be bypassed. There is now a patch for it. It was patched in July. You can go and get the patch if you're using or relying on Oracle data redaction. And if you are not happy with Oracle's performance, vote with your checkbook, vote with your pocketbook. Hold your vendors to a higher standard and make sure that in the year 2014, they're doing better, okay? Sorry, I'll step off my soapbox now. Any questions after all that? Sure. That's correct. Yeah. So the data is not being changed in any form or fashion. It's just what's being presented to the end user, essentially. So the data is still in that data block as forward 2111 and whatever kind of thing. It's just the policy basically turned around and said, oh, they've requested that column, so let's on the fly convert them to X's. Oh, there's other issues with here, by the way. If you have privileges on the DBMS Redact package, you can create policies in other people's, in other schemas, basically, or indeed undo them. And we can use this as a lateral SQL injection vector as well. So if someone has concatenated a number, for example, and there are a few flaws that Oracle are currently fixing, we can use the redaction. We can create a policy that basically says, instead of sending numbers back and have them embedded, send like some arbitrary SQL kind of stuff. So it itself becomes an attack mechanism for things like lateral SQL injection. So, but yeah, the data, in answer to your question, has not been changed. It's just the way it's presented to the end user. Any other? Okay, I'll come back. Sure. To be fair, I wouldn't call these exploits because they're really lame, you know? Carry on. In terms of like looking at functions that you might be able to use to bypass redaction and stuff like that. Well, there might be a product. There is no product that I'm aware of. It's just, you know, banging away and hacking at it. You know, a human is much better than a machine anyway, you know? In fact, Oracle have some tools that they use. They made some great investment into that, you know, improving security. And as I said, they've done well in certain areas. Like most PL SQL injection has vanished. They've done, it's where it switches from like PL SQL to Java or PL SQL to C. It's these boundaries where they're still a bit fuzzy on. Or, you know, things like numeric lateral SQL injection, because up until recently, they didn't think it was exploitable until I wrote a paper on it and showed it was still exploitable kind of thing, or was exploitable. But yeah, I mean, a human's going to be better than any tool to find these kind of things. Sure. The guy in the blue shirt, and then I'll come to you behind, sir.
So if you could guess, how long before you think Oracle data redaction could be useful?
Right. Right now, it is. Ooh, what does that mean? Right now, it's useful. To be fair, it was still useful beforehand because, you know, you had to know about these bypass issues anyway, kind of, you know. Are there more methods of bypassing it? Probably, based upon Oracle's track history. I personally don't have the, yeah, based upon their track history, I wouldn't be surprised. If they've gone and done a full product review, I'd be very surprised because that's not the way Oracle do things as far as security is concerned. They fix bugs as they're sent to people, you know, as they're sent bugs by people, they get fixed there, and then 2 lines, as I said, down of code later on, a similar issue exists, kind of, you know. So I'm not confident. Sure, question? Correct, it's not encrypted, it's just redacted. Well, if you're PCI compliant, you shouldn't be storing credit card information as well. I don't want this to be a focus on credit card stuff. I just wanted to make something, yeah. But yeah, I mean, if you're a merchant then, and you're taking credit card information, you shouldn't be storing credit card information anyway, as per the PCI requirements, you know, so. Yeah, well, they should be encrypted. If you happen to do something like that, you really should be encrypting. Well, see, here's the thing. I know some bugs that allow me to get full privileges over the database server, so even if you're encrypting it, I can get the information back out. You know, if when the database has been started up, you know, they've provided the password for the wallet and everything like that, and, you know, things like transparent data encryption is all going on in the background, you know, we can get that data out in an unencrypted fashion and stuff like that. So I would look to rely on external parties for encryption personally. But again, you're still going to have that level of, for the application to be usable, then there must be some level of encryption, decryption. So where are those keys and stuff? So yeah, there's no one solution fits all. And you know, if you want to take it offline, we can have a long discussion over email and stuff like that. But this is probably not the forum for that right now. Thanks. Sure.
So is it
No, they didn't. And to be fair, they're not supported products anymore, you know? But exactly. So the best you can do is actually, because Oracle, when a bug is found, Oracle don't give out any information. So you're left going, well, how do I protect against this, even though I'm running an unsupported product kind of thing? So I'm personally of the school of thought that this information needs to be put into the public domain so people can actually come up with risk mitigation strategies, even in the absence of a vendor supply patch. But Oracle, again, that school of thought where it's like, batten down the hatches, everyone needs to shut up kind of thing, and I just disagree with that. Sure, question? Yeah, well, they might not use the same language because they don't want to be seen dead using the same language as Microsoft, you know? But yeah, they've got internal processes that shouldn't be doing this kind of stuff, you know? In fact, they blog about it, they pay lip service to it, but the results don't show that, you know? Precisely. Yeah. I mean, that's the only takeaway I have from this talk is that it's not rocket science I've done here. This is simple. That's why I would never call them exploits, because, you know, they're not, you know? But it's being billed as a security feature, despite people saying, oh, but it's not a security feature. Well, they're selling it as a security feature in the most secure database server, you know? So if you're not going to sell something as a security feature, you know, don't put all your security improvements in Oracle 12c, because it's not, you know. It either is or it isn't. Make up your mind, kind of, you know. But yeah, a simple pen test should have found this, and guess what? It took people like me or Alexander Kornbrust to find it and report it. That's not what you want in 2014. You don't want external parties reporting problems in your products. You want to have closed those holes down before you ship. I would have thought. Any other questions? Did you had enough? Yeah.
What you're describing sounds like a hack that a company that spent millions of dollars on a query gateway product to solve exactly that sort of problem. Why would they not have leveraged other things like you, or do they share any information with you whatsoever?
No. And then here's another problem. I didn't really want to bring it up. I'm going to bring it up anyway since you touch on it. One of the flaws I have is critical. It allows public to gain full control of the database as SIS, okay? And I was flabbergasted when I saw this, and I actually said to them, first, why are you doing this? I'm not going to talk about the bug because of, you know, those things that I've said. It can allow anyone on the database to get SIS privileges. I said to them, why on earth would you do this? Show me the documentation, and guess what? They can't find any documentation either. They've got no idea why they're setting in this database that allows the public to gain full control as SIS. They've got no documentation on it. That's worrying, you know, as far as I'm concerned. It will all become clear in a couple of months when, you know, I publish, you know, what the flaw is, when Oracle actually fix it. But it's scary that there's no documentation internally as to why this setting has been made. So, any other? I think we're finishing about 13 minutes early, unless there are any other questions?
What I find a bit, I wouldn't say scary, but worrying maybe, is that they do a lot of other products than databases. And are these things, can they be found in, for example, their identity system?
Probably.
Exactly.
Yeah.
And were there
So I was downloading, or attempting to download, an Oracle product, Oracle Fusion Media Pack. 72 gigabytes, right? That's 72 gigabytes of attack surface for Oracle Fusion applications. That's scary. I mean, where'd you get 72 gigabytes of application code from? You know? Yeah, maybe. Big pictures or something, I don't know, big JPEGs. But anyway, so yeah, and all their other products, whether it be access management or e-business suite or whatever, there is massive, massive amounts of attack surface. And I think what's happened is they've had some really great ideas, you know, and they've thought, yeah, we can bring this to the internet, we can allow this functionality to happen, and people will be able to do business better, but they've done it with so much excitement, they've forgot about security, you know? So it's all about getting the product shipped and stuff so we can enable our customers. That's all very well and good, providing you do it in a secure fashion. So, you know, if we look at the difference between Microsoft and Oracle, I think that's what the issue is. Microsoft are doing great as far as the server side of things is concerned. Forget IE; they should have dumped IE a long time ago, in my opinion. It's really difficult to secure something if an attacker has full control over it in terms of things like scripting. So you're always going to have, you know, problems with that. But if we look at Microsoft Exchange Server, when was the last time you saw a decent bug in Microsoft Exchange Server? Version 5.5, like 10 years ago. Internet Information Server. When was the last time you saw a buffer overflow in an Internet Information Server? EI days, you know? When was the last time you saw, it doesn't matter, you get the point, okay? Microsoft are doing great on the server side of things, perhaps not so much on the client side of things. And with SQL Server, they've done triply great, you know, in my opinion. Okay, any other questions? Was that, I saw a hand go up there. Scratching his head. Right, okay, thank you very much, everybody. I hope this has been of use, and enjoy the rest of your time.